To get started, I'm Joe Lust. I'm an engineer at Mabel. We're a sponsor here at the conference. You might see our logo around. So obviously, we're into testing. I spend all my time building cloud testing infrastructure, and I really just live and breathe testing. And when I've been doing that, one thing's become really clear to me, and that's that quality engineering is playing a very critical role in our key industry trends. And that just makes it so exciting, to work on the product I do. And those trends that we see everywhere now, all those buzzwords like continuous integration, continuous deployment, continuous delivery, DevOps, or shifting to the cloud, all of these really depend on quality engineering being able to enable the high quality of product at the high velocity that they deliver it. And as I said, high velocity is the motif here. All these new buzzwords, they require us to move faster than before. So these pipelines that we use, where we basically put changes in one end and we get operational deployed SaaS products and web apps out the other side, it has to change more rapidly than ever before because the software industry is accelerating with a pace of innovation that's just never been seen before. And so we have all these tools, those buzzwords I just mentioned, that help us make these changes and operationalize them faster so that you can cope with changes in your configuration. Like, for example, you have a new feature flag for your application that needs to go out, or code changes to your server code or to your web app logic. And of course, upgrades. We always have to be upgrading in this day and age. With all the security threats we see, we're always upgrading. And finally, there are a lot of things that you might be depending on in your application or your company, external API dependencies, maybe you use Stripe, and all the dependencies that go into your code, which these days for some applications can be in the thousands. When any of these things change, we need to get an operational change out there. So we need a high velocity and high throughput development pipeline. But there's one thing missing in this diagram. I think you guys, since you're at this conference, you probably know what it is. That's right. It's quality, right? If we can just push changes out faster than ever before, we can push bugs out faster than ever before. So we really need a watchful eye in our system, in our pipeline, that's going to help us not only deploy changes quickly, but also deploy high quality quickly. Now, if you're like me, having a high level of automation on the tool that you're deploying, if it's a web app or a server, whatever it is you're working on, it gives me that security blanket. It lets me deploy at 3 p.m. on a Friday and feel confident that the code I'm pushing out there really is going to work, that I'm not going to get paged or called back. But don't just take my word for it. The State of DevOps report in 2020 by Puppeteer and Circle CI, it showed that teams that used high levels of automation and medium levels of automation had a 2 to 3x greater confidence in their deployments. Well, that's a great benefit, but it's not exactly where we find ourselves today. According to the 2020 GitLab survey, only 12% of teams reported having full test automation. And what do I mean by full test automation? Let me unpack that. By full test automation, I mean that your pipelines, your CI/CD, your build processes, they have automated as many test and quality gates as possible so that you can maximize your throughput. But I want to stress that doesn't mean that we're putting an end to exploratory testing. Actually, that is a very important part of quality engineering that having full test automation actually enables. When you're no longer doing rote tasks, you can do high-level cognitive tasks. You can upskill, and you can add even more tests. So it's actually a positive feedback loop. The more automation you add, the more automation you can add. And in total, putting this in your pipeline is really going to help accelerate that quality delivery. Now, as we said, we have a higher rate of change than ever before. And it's really crucial that QA adapt as well. We have all those new tools like Kubernetes, in operations, and we've got, all those CI/CD build tools, but QA, it really needs to expand its velocity such that it lets us realize the maximum throughput through your pipeline rather than crimp it down. And don't just take my word for it again. Very well-respected report, Forrester Wave, they observed, well, I'll let you read it for yourselves here, but to paraphrase, they observed that a lot of our test automation tools really are not keeping up. We have all these innovations on the making code, changing code, building code, and shipping code sides, but we're not getting those rapid innovations to help us cope with modern software deployment on the testing side. So what are we going to do about that? Well, I think what we really need to do about that is we need to add testing to our entire end-to-end DevOps pipeline. We need to test all the things, not just how we might have tested in the past, like maybe right before we deploy, but before we deploy, after we deploy, all the time. And this is really going to help us save time, catch bugs sooner, drive down costs because we're not doing things multiple times. And it's even going to let us use it as a monitoring tool. I know I just said a lot there, so let's unpack that. The benefits that I mentioned are generally threefold. One, we see increased test coverage because we can actually make tests faster. These numbers here are from some enterprise case studies we've done. You can find them in the Mabel customer case studies. And they showed 3 times faster test creation because the modern tools let you make tests that much more easily. And they let you maintain your tests much more easily. So you actually saw a reduction of 70% in the amount of time you spend maintaining tests. And for any of us that make tests, we know that the first thing you think when you make a test is, oh my goodness, now I'm going to have to deal with it when it breaks. So we need to not just make lots of tests, but we have to handle the maintenance of those tests we create. And finally, now that we're making more tests, have higher coverage and lower maintenance on that, we can actually deploy faster. And we found 50% reduction in deployment time. That is to say, people were deploying twice as fast once they pushed testing throughout their pipeline. So let's talk about these pipelines. Well, what's that look like? Well, the typical DevOps vision can kind of be broken down into 4 stages. As an example, we've got the code stage where we actually have to make a change. And then we're going to do a review of that code and merge it, typically in a pull request. And now we have to ship that code once it's merged. We have to deploy the code. And finally, we're going to run it somewhere, eventually in production, so that code can do something for us and deliver some value. So let's dive into each one of these stages and talk about how you can get testing and higher quality into these stages for higher velocity. So end-to-end testing automation at the code phase is critical. And let me just unpack that term for you if you're not familiar. End-to-end means that we're not just going and making sure in an isolated case that the button is there and we can click on it. End-to-end means we pop up the browser, we log in, we find the button, we click it, and now you get a high fidelity reproduction of what your user is going to see. So we're in the code stage, we're making changes. And I have a dirty secret as an engineer. Engineers are the source of your bugs, right? We don't mean to make bugs, but when we change code, we're going to introduce bugs. So this is the most important phase that we can pull quality into. The sooner we catch those bugs, the cheaper they're going to be to fix. So as you make these changes, we need to do simple tests, for example, headless testing, we'll talk about in a moment. And then we also need core test coverage, just so we have a quick feedback that we're not introducing bugs. And additionally, we really need a plan for quality, because we need to plan for quality when we start making the feature, when we start making the change, not as too often happens at the end when we're almost ready to ship it. Let's dive into that. So I talked about, running some quick tests. This is an example of Mabel's way we do this. We have a CLI, and the CLI is great because now you can have a very short dev test cycle. You make a change, you run your test, you decide if you broke something, you keep going. And when you can do this on your desktop, whether it's an integration with your IDE or on a CLI, now we're talking a second or two, right? Now we're saying you make a change, click, green, continue. Now, if you had to send this off to Jenkins and wait for the result, or if you had to let it run in the nightly batch job and then come back tomorrow or Monday and find out if you broke something, it would take you much longer to get that feedback. And that's why in modern testing, high velocity testing tools, you want to look for an integration with your IDE or your CLI like this. Additionally, it's really important that your testing tool have a way that you can branch tests. Because remember, we're branching the code, right? We're making a change to the code. So we should make a change to the tests that test the code. And we don't want to step on other people's toes. So it's really important that you have a way to branch your tests just like you branch your code. As an example, here in Mabel, we let you make as many branches as you need to, and now we can run your branch of tests and you don't step on other people's toes. The case in point would be if you change the login form, you need to change the test for the login form, right? Otherwise, if you ship one and then the other, you're going to break things. So make sure you have branching support in whatever tool you're using. Additionally, it's really important to establish a baseline of quality. In this case, we're talking about web apps. And with a web app, we want to make sure that we really hit all the pages in your web app. So that could give us a coverage score. And coverage in this case could mean of all the pages that exist in your app, here are the ones that you're testing. Now, I mentioned earlier, we want to have a testing plan. So before we start making changes, let's come up with a plan and a baseline. Okay, so maybe we had 87% coverage. And now as we continue, we can know if we got to 88 or 89, and we can also know if we dropped, right? If we got to 86 or 85, we must have missed something. So this is where understanding your existing coverage and then creating a plan for your coverage is a really important place to start so you can keep that quality baked in from the start. Okay, so we talked about developers making code changes. Eventually those code changes, they're going to get pushed out. Excuse me. They're going to get pushed out to wherever you keep your code. For example, GitHub or GitLab or Bitbucket. And now we need to review them. And it's my personal belief that this is really the most pivotal point in the quality process for DevOps and modern teams, because everybody has to collaborate here to make sure that we're shipping the right change. Excuse me. And why is that important? Well, if we ship breaking changes, then we've failed at quality. So we really need effective end-to-end tests to cover all the relevant areas. And we really need insights that are going to help us catch these changes as early as possible. And that's why in this diagram, you'll see per commit and PR approval. In this case, we say each time someone pushes a change, each commit, right? And there could be 100 commits that go into a pull request. We want to run like smoke tests for the API and the UI. We want to run quick headless UI tests, like cursory overview. But then before you merge your pull request, we want to do a deep thrashing of that code. We want to check, visual tests. Did weird elements change that shouldn't have? Does it work cross-browser on all the different browsers that are important to your users? Do all the relevant UI features work correctly? And the same goes for APIs and lower level interactions. So to unpack that a little bit, once we start using these sorts of rich tools, such as low-code solution like Mabel, we really start to be able to collaborate more. And that's the whole point of a pull request. For example, if you have an expert, a lead on quality in your organization, we want to make sure that they might review your changes. And so now, with Mabel, for example, we have a way to go and say, here's the logic that changed, and someone can come and see a human readable list of those changes. And this is really great for quality. People in your QA team can learn from one another. And it also is really democratizing because everybody can look at this. Your product manager or your business analyst can go and look at this and say, that makes sense. And it's not just, looking at code, which is what pull requests more traditionally have been. And additionally, you can easily see the logic that's being applied, and the framework in the meantime can go and abstract away those complexities of, as mentioned here, timing and parallelization. You don't need to worry about that. Just worry about what you're testing. So collaborative views like this really help all the participants in your team. And that's going to help you make better tests and make them more quickly. I mentioned, running regression tests. One thing I think is really important. This is one of my favorite things. It's something you might have in your team or not yet, but it's preview environments. And the important part here is you're going to test the code being deployed somewhere before you merge it. Traditionally, we merge to integration and then we found out the integration tests failed, right? Or you might merge to UAT or QA environment and then find out that it broke. And of course, you maybe only had 3 environments. So now you find out in Slack from your coworkers that you broke the build and you broke the environment. With preview environments, every build, every change gets its own environment. And now we can do a deep, detailed set of tests. So we're not afraid of breaking the build anymore. We're not afraid of breaking integration or UAT. And it really lets you, again, do a more pervasive, depth first quality search here, test everything, and then make sure we don't ship that to prod or to your main branch. Because your testing framework that you use, it really should tell you at the PR stage if you broke something, not when your team members tell you that you broke the master build. Now, those are the first two stages, right? Code changes, then pull requests. But now we actually need to deploy it. And that's the operative part of our deployment pipeline. And the reason that we're doing this is that we really want to make sure no defects get into production. And that's why we need even more comprehensive testing at this stage. And we also really want to make sure we find a broad measure of quality. And I'll unpack that in a moment. But what I mean is we're just not looking for a red, green, or a yes, no, pass, fail. We're looking for a much more nuanced, subjective view into the quality of your application, such as mentioned here, performance or different browser permutations, which we'll get into in a moment. First, I mentioned we want to have lots of coverage. And obviously adding test coverage, this can be a little bit tedious. That's why when we try to be fully automated, it's really important to harness data-driven testing. You might already be familiar with this in some tools, but what it is, more modern testing tools is you create one test, let's say one flow through your application. Let's take an example of a calculator application, right? We put a number in, we say plus, and we say equals, right? Something like that. Well, now we make one test, 1 + 1 = 3, and we can parameterize that. We can now take a table of scenarios and we can test 100 of them. And you didn't write a single additional line of tests. And more importantly, anyone on your team can do that, right? Your business analyst can come in and say, oh, I just thought of another case we need to test, and go and add that scenario as just one more line in the table, and you've got the test coverage. So now, again, it's really democratizing because everybody can contribute, and you get a real force multiplying aspect through using data-driven testing to up your coverage. Now, there are other really awesome tools that you should find out there in a modern testing toolkit today, like realistic generated data. Oftentimes, we might have kind of simple data, right? Every single user in your system is, John Smith or Sarah or something like that. And that's not going to catch all the bugs that can really exist. As an example, I used to work at a big financial corporation, and we're in Boston, and there's people with Irish names, and Irish names can have apostrophes in them. And we would find all of these SQL injection attack vectors because someone typed, Sarah O'Reilly into a box. We didn't catch that automatically. We didn't catch that unit testing. Just a person typing in a real name, a real piece of content triggered it. And that's where data generators, which you'll find in modern testing tools like in Mabel, libraries like Faker.js, they're going to let you catch names that are too short, names that are too long. They're going to let you catch odd characters, overflows, and things like that. So this, again, is another force multiplier where you didn't have to write any code, and you really got an increase in your test coverage and your ability to flush out bugs you wouldn't have otherwise found. Another wrinkle we see in modern applications that we all have to deal with now are what are called, responsive applications, or like responsive web apps. And these have a variable form factor. For example, it might have one shape when you view the web app on your monitor, one shape on your laptop, and then it looks totally different on your phone, but it's the same application. Well, you can go and write 3 different test suites, or you can use a feature in modern tools like, support for responsive, viewports. And when you do that, now all you have to do, again, with no code changes, is just say, I want all these different permutations, right? I want an iPad, and I want a Samsung Galaxy, and I want an iPhone 11. And then your framework should just be able to do this for you, abstract that away. And that's the sort of, feature that's really going to help you accelerate your, development, because now you don't have to keep that drawer full of old iPads and phones in your desk like too many organizations have. I know I've had to work with it in the past. And again, that's just an example of what you can find in full test automation. Now, we mentioned all these new ways to get extra coverage data, right? We've got this fire hose now because we've got our data-driven tests. We got 100 permutations or 1,000 permutations. And we've got all these new realistic data permutations being generated, by our generators. And we're testing all these different, responsive layouts, for different browsers. We need a way, to sip from the fire hose rather than to be drowned by it. So that's why any modern testing tool you're going to use, it's really important that it helps you boil down the ocean. It helps you just get insightful output rather than drowning you in, millions of lines of logs. And it's also important that it just tells the right people. So as an example, the sort of thing you should be looking for, integrations with messaging apps are great. And this example here on the left, we have Mabel's integration with Slack that's just telling the developers in their Slack channel, hey, we just discovered a JavaScript error. And this, again, is getting into the subjective quality. We're not telling you that the test passed or failed because there's a JavaScript error and the test did pass, right? All of the assertions worked out, but we discovered that there was a new error in the JavaScript console. And this is how you can get that subjective, non-binary, not, up, down, pass, fail, but a higher level of quality and insight from your testing tools. Additionally, you really want to make sure that all this data you've got, this fire hose that you're consuming, has a great set of surfaces to help you produce shared views for everybody in your organization to see quality. As an example here on the right, we've got some screens in Mabel that let you see performance. Now, remember, you might have a test and the test passed, but it went from passing in 30 seconds to 3 minutes. So for some reason, our web app is taking 3 minutes to load, right? It's taking like almost 10 times as long to load. What's going on? Well, this is where you're going to start discovering those sorts of insights. And because you can create these views, anybody can consume it. Folks don't have to go and bother a quality engineer and say, hey, give me the report. A manager can come and see this, or an engineer can come and see what happened to the change they shipped last week. It's highly democratizing again, and it helps everybody focus on quality. And again, this is the sort of thing you should be looking for in a total, full automation solution. Finally, we did mention again this fire hose, which means we might start discovering more bugs, right? We have all this great data to go through, so we find more bugs, but you really shouldn't be spending all of your time filing bugs, right? If we're trying to automate everything we can, we should try to get some automation at that bug filing level as well. And so, whatever tool you're using, whatever modern tool, you really want to look at, integrations with your bug tracking tools. So, to use X-Ray, to use, Jira or Quality Center. Well, let's find, an integration. Here's the example of Mabel of just create Jira issue. I know I've filed thousands of tickets over my life. I've spent so much time filling out all those, different drop downs and typing in, copy pasting and typing in and bringing in screenshots. Well, let the tool do the work for you. And so you can go and really focus exploratory testing or finding other bugs rather than spending all the time filling out tickets. Make sure you've got great, built-in bug tracking features. And finally, you can see here, have it be bidirectional. That is to say, if the test passes over here, let's go update the ticket. Because how many times do we spend our time running back and forth, filling out tickets and updating them? So again, really let your solution work for you in the bug tracking space. Okay, so I won't spend too much time on this phase, but this is where the rubber meets the road, right? The deployment of your code into production. The code does useful work for you. I want to note that traditional testing in production is actually still relevant. And that might sound a little weird, but what I mean by that is you've written all these great tests. They cover this massive surface of quality for your app. Why would you only run them when you're building your code? Why not run them when you ship the code, let's say on Friday evening, and at 3 a.m. on Sunday morning? Because sometimes things break over the weekends. Sometimes things break after you've deployed them. And that's where, you get a great monitoring tool in the tests that you've already invested in building. And additionally, it really ensures that your application continues to function as your users need it to function. That is to say, maybe you have, Pingdom making sure that your website loads, but if people can't click and log in or use your shopping cart, they can't use your app. So those end-to-end tests that you just invested in making in all these other stages of the pipeline also deliver a lot of value and help you discover bugs more rapidly as a monitoring tool once you've deployed it. So that's another great place to use this full automation Though, again, as I said earlier, exploratory testing is still really valuable at that stage too, to discover the unknown unknowns. So to summarize, it's really important that we test early, we test often, and we test everywhere throughout that DevOps pipeline. And of course, our main thesis, automatically test it as much as you can. Try to achieve full test automation. So I'll take just one final moment here, a quick little plug. You might have noticed, as I said in the beginning of the session, I work for Mabel, big fan of testing. We think we've got a great vision for where testing is going, where the industry is going, as everybody tries to keep up with the high velocity of innovation. I think we've made a great product. There's some other products like it you might have seen at today's conference. I think, though, you're going to like ours the best. I might be partial. And I'd encourage you just to come and give it a try. If you just go to mabel.com, it's totally free for a 2-week trial, no credit card, no nothing, just give it a try. And I think you'll find that all the features we talked about, like coverage, all those force multipliers that are going to help you, speed up development and increase quality in your workflows really are awesome. Thanks again, and I'd love to take your questions.
Awesome presentation, Joe. Very insightful. Any questions? You can either throw them in the chat or I guess you could unmute yourself and ask them quick to Joe.
Hey, Joe. Can you hear me okay?
Sure, yes.
Yeah. So you mentioned automate bug logging. Do you find that you get an overflow of bugs now that it's automated and possibly spend a lot of time kind of searching for valid bugs?
Sure, Eddie, that's a great question. And thank you for speaking up. Don't have to repeat it for everybody. On the topic of automating filing a Jira ticket, you're right. That might sound like it's a little dangerous, right? That you come in on Monday morning and there's 85,000 new tickets. What I'm really advocating there is automate as much of that process as you can. So as an example, one thing we've done in Jira is we tried to say, there's a button, and when you click it to file a Jira ticket, we're going to put like links back to the test. Here's like the screenshot that you were on for the failing step. Like here are the logs, things of that nature. Don't make you have to go download stuff and then put it back in there. You're probably still going to add, your high level insight. You're going to probably say like, oh, wait, isn't this what, Jim broke last week and fixed? Maybe we didn't fix it. That's where like, the human component comes in. But the automation component is just trying to really reduce the overhead of like, filling out all those forms and collecting all that data.
Gotcha. All right. Thank you.
Thank you.
Hi, Joe. I had a question specifically about end-to-end tests. One of the challenges that we face on our team, and this is trying to get into more of a CI/CD flow, so trying to be able to do quick releases, is not just the complexity of our web app, but more specifically the complexity of our use cases, our workflows within the application. And I've been able to build out a pretty complex end-to-end or regression suite, but some of those end-to-end tests can take quite a while. They can take 20, 30 minutes to run because they rely on other systems to process data. Do you have more specifically, do you have any recommendations on how to kind of compress that time? Because right now we just have to kind of rely on like nightly regression runs because it can take so long.
Gotcha.
Ways to kind of pinch that down so that we can fit more useful end-to-end test into like a build cycle that can go out quickly.
Sure. I guess I'd say a few things to that. Just to ask you one question back real quick. Do you mean that like you're running these in series, and so by the time you run all of them, it's taking hours?
Yeah. So yeah, that. I understand that that's one limitation. Yeah. Okay. So it's one runs, then the next one will pick up.
Sure. So, one thing I didn't really talk about in the talk much, but, now that there's a lot of cloud tools out there, if you can harness anything like that, and you don't even have to be using the most modern tools for that, Jenkins and TeamCity, things like that have a lot of like cloud integrations now, but, there are ways you can say, I want to spin up a bunch of boxes, like, with containers and Kubernetes these days, and try to run as many of these in parallel as I can. And I understand that might not be an easy thing to start. But when you do stuff like that, in the cloud, you can run pretty much unlimited parallelism. So we generally do that. If you say run 1,000 tests, we spin up 1,000 servers, run 1,000 tests and take them down. Beyond that, though, there are ways you can, kind of try to see, is there something you can mock? If you're waiting on a backend process, maybe there's a way you can mock that. You'll find that in some tools now to mock API, responses and requests. And then finally, I touched on it a little bit between the code change and the pull request change, but you can always try to change the level of testing you're doing. Is there some core smoke test you can do? It's just a few tests, and then a more pervasive test you could do, and then the full shakedown test. That's also another thing you could do to have different levels of testing. With how many tests you're running, and then you can only run that full big bang test when you really need it. And even though that, as you said, might end up being a night job.
Got it. Thanks. Those are great ideas. Thank you.
Thank you, Ben.
Joe, we have a question here from an audience member that says, how do you handle builds in different environments? For example, dev, staging, prod, any version control, tools, recommendations?
Sure. I mean, there's all sorts of tools out there. You can be using, GitLab or GitHub or, Bitbucket. We know a lot of people that, customers that use all of those, and they're all really great. I think what you got onto, though, was the challenge between environments. And that can be a little, complicated. The way we tried to build things at Mabel is we considered each environment different. So if we had a detection of an issue, each of those three environments we considered separate. If we found that some pixels changed, each one is considered separate. I know that's kind of easier said than done. But any way you can kind of isolate those changes can also be helpful. But finally, it really comes down to how you implement your pipeline. How you decide to deploy to environment A, B, and C. I know that was pretty general. If there's any more details you have, I could try to expand further.
Great. I think we have questions for time for a couple more questions. I actually had one myself. Curious about, you talked about running tests, after a commit or a PR. Can you just talk a little bit more about how you do that at Mabel? What that looks like?
Sure. So I mentioned, preview environments, or you might have heard them as ephemeral environments. It's kind of something that's bleeding edge right now, I'd say, for quality engineering. But what we do, and if you go and search, you'll find a few blog posts we put on this, because it's kind of complicated to do. But we use a lot of modern cloud tech internally. If you're using Amazon buckets or Google Cloud Buckets or Azure Blob Store, you can take a single page application, for example, and you can host it for almost $0. So that's what we do at Mabel internally. Every single commit on all of our repos gets pushed out. We have right now thousands of different environments. But because it's just some files in a bucket, it literally costs 10 cents a month altogether. So that's kind of a game-changing technology. It depends on your application, whether it's stateless enough that you can deploy a lot of environments. Sometimes environments can be really complicated, and so you can't have very many of them. But if you can, that really lets you, as I said, run every single commit. And the final thing I would just note on that is, if you can test every commit, then you can just start, you're changing code, and you're just commit, push. And only when you see that email pop up that says that something broke, then you notice, right? But you're not wasting, your valuable, cycles on your computer and your time running the test. You're letting the machine run the test for you. And then it's going to come back and give you, insight. So that's really the value of running at each commit. But again, the preview environments, your mileage may vary on, what your application is.
Yeah, great. I'll definitely look into that. I think we have time for one more question. If there's anyone in the audience that has any questions. Doesn't look like that. Okay. Well, thanks again so much for your talk. Really thought it was insightful. I have a link to a survey that you can share some anonymous information so that Joe can get some feedback on his talk. But well, thank you so much for your talk, Joe.
Yes. And thank you, everybody. Have a great day.